everyone. Thank you. So I'm Nick, and I am the lead GIS and data analyst working at Zero Invasive Predators. So this talk here is about how QField empowers Zip's mission alongside other open source products for a predator-free New Zealand. In the sort of the line of work that we do, often we're very much focused on removing predators, and we also need to just remember that the outcomes of our work are things like the biodiversity and the native forests and stuff that we protect. So throughout this presentation, I've used a lot of photos that have been taken from one of our field rangers, Chad Cottle. So props to him for taking a lot of these images. So who is Zero Invasive Predators? So we transform Aotearoa's wild places by removing pests and also valuing the carbon that we create. So we're taking on the challenge of landscape scale predator removal without the use of fences or any other kind of man-made boundary. We're made up of field rangers, engineers, ecologists, scientists, and then there's a couple of GIS people involved in there as well. The three main species that we target through our work are stoats, rats, and possums, although across a couple of other projects that sort of target species list has it just accounts for what is at that particular area. So other areas we're targeting hedgehogs and rabbits and hares or cats, but it's very site specific. So in this one, I'm just going to cover off like where we started, the open source stack that we utilise, some of the field workflows that we use, some of the growth and change that we've experienced as a business and how open source has supported that, and then where we're going. So what we do, large scale predator eradication. One of our field sites on the west coast, it's 100,000 hectares. We have no fences, we just utilise natural barriers, so the Southern Alps, high mountain areas and reasonably strong rivers. This is some of the tool set that we use, so taking or eradicating predators, there's no one tool fits the job, you've got to approach it from many different angles. So we do a lot of research and development. The top left there is a trap designed and developed in Zip called our Zip-In. It's a rat and stoat trap. On the top there is a little node, and the node, when this trap goes off, sends a signal via comms, so satellite comms, and then our field rangers are advised that they've got to go and check that trap because it's been set off. So these type of, small advancements, it's still a trap, but these small advancements mean the field rangers are only going out and servicing traps that need to be serviced. They're not servicing everything. Also on that same trap, we've got it's a moto lure, and it pushes a fresh bit of mayonnaise out every single day, just keeping the lure fresh, keeping those animals coming in. The possum cage trap in the middle, again, it's noded, so legally you have to check a cage trap every day through making sure there's no animals trapped in there. So again, we've put a node system on that to let the rangers know that it's gone off, so they can go straight away and dispatch what's caught in that trap. We use scent dogs for narrowing down on where we've seen species. The one, here is it? It's down the bottom next to the dogs, quite an interesting one. It's if you can see, it's a rat. It's what we call our toxic rodent. So from our work, we found after an operation, the buy-kill for stoats was 100%. So we thought, how can we mimic this? So we now take rats, we poison them in the lab, we freeze them, and then we put them at areas where we detect stoats on our trail camera or AI network, and it works really well. A couple other devices there, trail cameras, and on the bottom right, one of our AI cameras. So it's got a thermal AI camera in it. As the animal comes underneath, the thermal unit turns on, and AI looks at the video sequence through that, detects what it is, and then sends a message out through the comms network, so that we know where a species is, but also being able to respond to that very, very quickly. So where we started back in 2015, very small op, kind of spun out of the Department of Conservation, and we started on some small kind of 400 hectare blocks, but the main landscape sort of scale was in the Perth Valley on the west coast. So the map on the top left there is kind of the boundary. It's 12,000 hectares. It's very mountainous, very rugged terrain. But the nice thing with it is it's got two reasonably strong rivers and then backs up to the Southern Alps, so protected on nearly all sides. It was a good place to start testing these devices that we use in the field, and developing them so that they can become more efficient and better. Also on the map on the bottom right shows some of the projects we work in today. So Stewart Island, 170,000 hectares, and our Te Manahuna Aoraki project, which is 300,000 hectares around there. So the work that we do has a positive impact on biodiversity and the environment, so it seemed very fitting that we utilise open source projects, which also provide positive impact for community. And it's a very stable and strong software stack, and has allowed us to scale our work and manage all the change that comes with research and development. So some of the field workflows that we use, so we use that full open source stack. QGIS is our main desktop app, and a lot of the planning and the reporting and the analysis all happens in QGIS. Then using QField, so put the project out to QField so that the team in the field can go and implement that work or service the devices. And then QFieldCloud has been a bit of a game changer for us. We were very much hanging out for it when it was, I think 2020 it was meant to be first released, and then delayed, thanks COVID. But now that it's in place, our team is absolutely loving it. So some of the field workflows will go through our detection networks, so that's using trail cameras, AI cameras, our automated traps, bait stations, so using our bait stations across sites, specifically in farmland areas or non-dense bush areas. The bait hand lay, so alongside aerial operations there'll be areas we can't get helicopters to, so we'll come in and do hand lay with people. The hunting operations, so using our thermal drone or using thermal drones in night hunting to get species to zero, and a little bit on carbon monitoring, which is kind of where we're heading as a business. So detection networks, this is just a screenshot of one of our QGIS master projects. Across there we manage all the deployment, so the technical team will look at what we need to be deploying where, so what the density of our detection network needs to be, where we need to be putting them, in areas along our boundaries where we get more pressure from predators coming in, we'll have a denser network there, but in our core area the density will be less. So the technical team plan all of that out, then when they're reasonably happy with the design and the numbers, they put that back into our database, and then push it through to the field team, who have a quick look over to make sure that the point locations make sense, and then out for QFieldCloud, and then next day they'll be starting to deploy or service what needs to be there. And then So screenshots from the QField app itself. I say QField, what we chuck at it it's baffling. Like, that's our entire project, 100,000 hectares, tens of thousands of points, all in and on your phone. As you can see, that first map is very, very busy. So we make use of themes. So each of our we call them a device system. So whether it's trail camera setup, AI camera setup, we'll break that down into a theme so the field ranger can very, very quickly and easily switch between the work that they're doing and only see what they need to see. Alongside that, we'll put on health and safety layers, so where our helicopter loading sites are, wasp nests, areas where there's no cell reception or bad radio coverage. So having that all at their fingertips, super, super helpful in the field. So then we zoom into an area. Those there are some of our AI camera locations, the stars. Maybe it's trail cameras, one of the two. Then clicking on one of those, they can then enter deployment items or servicing items based on that device. One of the strong bits around using this is being research and development. It's not like we take a trap and then we just put it in the field. We take a trap design, we put it in the field, and then after a couple months we figure out that this component doesn't work. So now we have to change that component. So it's knowing which devices need to be updated, but knowing what component of that device needs to be updated. So the flexibility that QField and QGIS allows all of this for us. One of the funny ones that we did have was our zip-in traps. The treadle system that closes the doors was designed for the weights of rats, about 120 grams, and that would supposedly exclude mice from setting a trap off. But mice were coming in, they were climbing up where the lure comes from the top of the trap, and as they jump down, they exert the same force as a 120 gram rat. So that meant back to the engineering and designing what we called a mouse excluder. So it's a little piece which stopped mice from climbing up the top inside the trap and being able to jump down. So there's all these little pieces and all the modifications we have to track and make sure that the device in the field is using those or knowing what is left to change. As I was saying, with each of the devices, we have our related tables, recording the deployment of certain things for that device, and some devices could have 20 or 30 components over their lifetime that need to be deployed onto that, and then we also have to know, has that thing been taken off there. And then down to the servicing, and having all of the predefined drop downs set in the attribute forms in QGIS makes this really, really easy, but also gives the field team the ability to set what they want to see. It makes it quick for the field team or field rangers to record things. So they click on a site location, they go into, say, the servicing table, add a new record, the date times automatically populated, their users automatically populated, so we know who, we know when, and then they just push the drop down, select this is what I do, then they move on to the next one. This one here is bait stations. This one's quite impressive. We've probably got 15 or 20,000 bait stations across this 100,000 hectare site, and we're recently changing the lure system on all of those bait stations. So traditionally the bait station had Brody blocks inside, and we're moving to a new device called we call it H20, which is like a giant syringe with a hydrogen pump at the top, and it pushes out laced mayonnaise with a toxin called Redentathor. The benefit of that is these lures last 9 months, not having to go service Brody blocks every 3 weeks. But that's all of the bait stations across our site have to be updated and changed, and having 20 field staff working on the replacement of this, using QGIS and QField and Cloud to manage all of those changes, keeping track of what was done in the day, keeping track of what's left to do, and then feeds into the plan of how many work hours are left in the particular stint, and it's working fantastically. Quick screenshots using QField. The other nice thing is we put a lot of boundaries in there, so we've got parcel boundaries. So each parcel we go on, private parcel, we have to get permission, and then based on that permission we're allowed to do certain things. So a field ranger can see the bait stations they've got a service, they can click on the parcel and they can get the permission requirements, whether they need to contact that person, who they have to do, what they can and can't do, like bring dogs onto the property or bring firearms, etc. So again, having all the information at their fingertips means there's no having to call back to their team lead and say, what do I need to do here? It's just there, they can see it. Over to Twizel, so our Te Mana Huna Aoraki project, different suite of animals we're targeting there. We're still doing possums, rat and stoats, but we also do ferrets, hedgehogs, rabbits and hares. Rabbits are particularly tricky, they breed extremely fast, and they can be quite elusive, especially when you're getting down to those last couple. So we use a lot of trail cameras for our detection, and during the day the team will be looking at the camera images, figuring out where the detections are, and then plugging that into the QGIS map, and then they'll symbolise that based on when was the detection seen, alongside our previous hunting work to know where we've had a animal kill, and then they work out a hunting plan for that night. When they go out to go, these are the areas we're targeting, we've seen a rabbit here in the last week, we'll go there first, we've seen one over here in 2 weeks, but there was a kill there, so we kind of know that that rabbit's probably been dealt with. So yeah, being able to go from planning, pushing out to their phones, and then working at night time with this, and there's a lot going on at night time. They've got thermal drones flying around, they've got hunters with guns with being directed where they need to go. Rabbits will appear and then you'll go there and then they'll go to ground and you lose them, so then you've got to record, okay, I've seen a rabbit here, I might have to come back a couple hours later and wait for that rabbit to come up. So again, very, very powerful setup of being able to go quickly from data to action, or to planning to action, all within a day. A couple of screenshots again from QField on the data that the hunter is able to see when they're there. Bait hand lay. So when we do an aerial operation with this bait from a helicopter, we can get as close as we can to sensitive boundaries, but there's always an area, whether it's near farmland or near houses, we just can't get the helicopter that close, not safe to, and we don't want bait landing on houses if we can help it. So we'll send field rangers out to do hand lay projects, or hand lay. So we define the points, which are all spaced at 20 metres, and the nice thing with this is we'll have a GIS person on the load site with the helicopters going. As the helicopters complete their section of aerial, then the GIS analyst will create the points and say these are the areas that the bait lay has to be put, and then upload it, and we've got Starlink on the load site. Then the field team will download it and off they go and doing hand lay, so there's no having to go back to the office and sort this out, it's all just flows really, really nicely. And then with the hand lay, we have to know where they've put bait, where they were unable to put bait, and then that helps define areas that may have been missed. So very simple, the points are all preloaded, they just click on a point, put the drop down, and the date, times and stuff all pre-populated when they open that point. An area that we're kind of branching out into is carbon sequestration. So the crux behind this is a healthy forest should be able to sequester more carbon than an unhealthy forest. So if we take away the browsers, take away the possums, then the trees should sequester more carbon. So we're doing a lot of work in this space, deploying vegetation plots, deploying dendrometers. So dendrometer is a little device that just measures essentially the growth of a tree. Screw it into the trunk of a tree, and at like very, very small increments it'll measure the change. So all of these devices need to be deployed, they need to be serviced. The vegetation stuff, vegetation plots is have an area, then within 200 metres of your central point you've got to map all of your large trees, how big they are they dead, are they alive, what type of species they are, and then in smaller areas within that plot mapping all of the seedlings, how high they are, how many, so all that information needs to be captured, and that's our intention, is to be able to use QField to capture that, and I don't see why it can't. It's just we've got to put a bit of time to figure out what are the different drop downs that we need and the categories of or species of tree that we have out there. A little bit just on, I guess, the scalability. So we implemented QField in around 2020. At that point in time we were using QField Sync to do offline projects. It got to a point where it was quite cumbersome to take 30 field ranges, QField projects, take them off the phones, process them, and then put 30 projects back onto field ranger phones for them to go back out. We used to do that on a stint by stint, so there would be sort of a week and a half to 2 weeks delay of data that was captured on devices to going in into our main system. Then QField Cloud came along, and all of a sudden just daily data comes in, daily data goes out. But this is the kind of the increase in records that we're recording on a monthly basis. So we're upward nearly 20,000 records in a month now, and yeah, the system just handles it. So I can't see any issues with us scaling even bigger. So where we're going, we've shown that we can eradicate predators from landscape size areas in New Zealand. We've shown that in our predator-free Southwestern project. We're currently doing that in our Te Manahuna Aoraki project around Twizel. We've just taken on predator-free Rakiura, which is Stewart Island. So that's our kind of plan right now, but I guess our goal for the future is to end up doing the entire West Coast. So that's 5 million plus hectares, whereas at the moment we're managing about 200 to 250,000 hectares. So yeah, that's where we're heading. And last, just big shout out to the open source community. All of the work that you put in, it's definitely helped us out with our projects. And yeah, we wouldn't be able to do the work we do without having this fantastic software suite and behind the scenes. Yeah, happy to answer any questions if anyone has any.
Thank you, Nick. Any questions? We'll take 2 because we're running.
Great presentation, Nick.
Thanks.
What is Zip's approach for sharing data, either as open data or as selling data to raise money to support pest eradication?
We don't have a system in place to share data availably, easily. But in saying that, if anyone is after data, then just contact me. We're not protective if it's not sensitive. We're not protective. So our detection network data, we're up over 30 million records, of which 14 are animal detections. Recently we gave 2 to 3 million trail camera images to a guy at Doc, Yoris, who used that to train a AI model called Alita. which essentially looks at trail camera images and just classifies what it is. So yeah, we're very open to handing out data if you're interested.
That was a very good presentation. You obviously have like a sort of a sensor network or data streaming in and out. Do you have a separate presentation about how you manage that? This was mostly about field work and getting data by hand. You obviously have an automated system as well. And the other question I had was about, you said AI camera a few times. I assume it's an onboard AI. It's just running on the device.
Yep.
What is that?
So in-house developed AI camera from our engineering team from WildTech in Christchurch. So yeah, it's a thermal camera and then AI unit on the side, IR sensors. So the unit is essentially asleep, and then as the IR sensors pick up any movement, the thermal camera starts up. The AI unit then takes 10 to 20 seconds to start up. So yeah, all built in-house and managed in-house. Our data streaming, again, WildTech have managed the satellite comms network side, so all of our noded traps, the AI units, they manage all of the comms through little sat boxes which are on site near our devices, and they also manage a Django web server to digest that, and then they have an API which we then feed off the API to make sure our systems are up to date with detections, and we use Apache Airflow for all of that data movement.
Great. Thank you again, Nick, for your presentation. We're out of time. Sorry, I have to draw the line, but